Okay, so in this video, we want to quickly review how to obtain the graph of the cube root function. But if you recall, the cube root function is the graph of the cubic function. So let us first sketch a graph of y equals x cubed. So for positive x values first, well, as you cube larger and larger numbers, the result is going to get larger and larger and larger. And 0 cubed is 0, so the graph looks a little something like this. And the difference is, for negative values, that when you cube a negative, you get a negative. So you get the exact same shape, but going towards the negative y values. So the two pieces are exactly the same, but one being going up positive, the other going down negative. So this is the graph of y equals x cubed. And as we've just stated, the cube root function, y equals cube root of x, is by definition the inverse of the cube function. And if we have the graph of the original function, we can obtain the graph of its inverse function by reflecting about the line y equals x. And again, y equals x cuts the first quadrant right down the middle. And as 1 cubed is 1, we have here the point 1 for x, 1 for y, and for the negative values, negative 1 cubed is negative 1. So we have the point negative 1, negative 1. So there are two pieces to the cubic function. Let's reflect one at a time. So again, the cubic function goes underneath between 0 and 1, the line y equals x. Once reflected, the mirror image will be above. And if you look at the cube function, when x goes to infinity, y goes to infinity. So the same will be true of the cube root function. When x goes to infinity, y will also go to infinity. So we can write y equals the cube root of x, or equivalently, y equals x to the power of 1 over 3. But now we only have half of our graph, because we've only reflected this piece of the cubic function. Let us now reflect the other piece. So now this piece is above the line y equals x, so its mirror image, its reflection will be below. And when x goes to negative infinity, the y values on the cubic function go to negative infinity, so the same will be true of the cube root function. When x goes to negative infinity, y will also go to negative infinity, but of course not as fast as the cube function. So let us now simply redraw the sketch of both functions separately, right? This is the graph of x cubed, and this is the graph of the cube root of x. My picture is a little crooked here, but this should be perfectly symmetrical about the y-axis, except that these are the negative values of these ones. This is the graph of y equals x cubed, and its inverse function, being the cube root of x, goes like this. So we have the graph of the inverse function of the cubic function, basically being the cube root of x. And as always, to obtain the graph, sketch the original function and reflect that about the line y equals x to obtain the graph of the inverse function. And this is how you can quickly obtain the graph of the cube root function from the graph of the cubic function.